All right, welcome back. We are Game 3001, that's Artificial Intelligence for Games at George Brown, and it's in the winter 2022 semester, and it's week 14, part 1 of our broadcast and recording. And today we're going to be talking about a couple things. One of them is tactical and strategic AI. So that is the where we're going to start today. Last week we talked about utility theory and something else called action execution. Where we talked a lot about actions in the past, but we said, well, how do you do an action? How do you implement an action? We also completed Lab 7, parts 1, 2, and 3 were due last weekend. And what this did for us is it kind of pushed you towards the final direction of your assignment 4, which is coming up this weekend. Okay, that's what we did. There's also more we're going to give you today with a separate lab. Smaller lab from an evaluation perspective. So today we're talking about tactical and strategic AI, including technical pathfinding and waypoints and a bunch of other stuff that's really cool. Lab 8, instead of it being due this Sunday like normal, we're going to make it due this Saturday. So that way you can do your individual component on Saturday and then your group component on Sunday. Again, it's worth 4% of your final grades. Please don't take it lightly. Stuff that is due this week. So assignment 4, again, is this Sunday at midnight. So that is your culminating assignment for this class. And I mean that in terms of assignment 3 and assignment 4 were kind of combined into or separated into 2 different assignments, but it's really one big assignment. It's decision making. And then also I've released assignment 5, which I'm going to describe today. Assignment 5 is a little different in that even though it's due next week, it's going to be due on Wednesday of next week, right? And you will present with your groups on Thursday. Okay, so that's a little bit different than what we had done in the past for other assignments, because this is your culminating assignment. Think about this as your final exam in this course. So one thing to note is that there are no extensions for this assignment. If you don't get your final assignment submitted by Wednesday, your group will get 0 on it. Okay, that's how it goes. And we'll talk about it in a second. There's 2 parts of the assignment though. One part is your submission when it's due, and the other part is actually your presentation, which is going to happen on the Thursday of the lab week. So we'll talk about that in a second. So again, we're sitting at week 14, and we're talking about things like tactical pathfinding and so on. And next week, again, is the final week of class. We will have a lecture on the Tuesday where we'll talk about machine learning and a little bit of reinforcement learning. Think about this as your special topics week that we're going to be using. And then during lab times, we're going to be doing the assignment 5 presentations. That is what the plan is for next week. Okay, so again, we'll go over that again. As well on the Tuesday, I will also take any questions you might have for anything that you're concerned about for your presentation that is going to be due on the Wednesday. The actual physical presentation must be submitted with your video. You're going to also make a video for your presentation, and then you must have everything ready to go for your lab on the Wednesday. Okay, so we'll talk about that in a bit. Let's get into what this presentation is and what you're going to be doing. Again, this stuff has been submitted to you, right? So that it's been released, I should say, so that way you can view it. Okay, it's in PDF format. So assignment 5, when is it due? It's due April 20th, and if we look at the calendar, that is next Wednesday. Okay, it's not next Sunday or some other time of the week. It's next Wednesday. All right. So why next Wednesday? In the middle of the week, it's because Thursday you're doing your presentation, so you must have everything ready by Wednesday night at midnight. It's not going to be like 7 o'clock in the morning by Thursday. That doesn't make any sense. So it's going to be Wednesday at midnight is when this thing is going to be due. So what is this thing and what are you doing? So your team will present the final version of your decision-making assignment, which is really A3 and A4. For this semester. You must be prepared to present live. Use a slide deck during your presentation to keep you organized. Your presentation should be no longer than, I'm saying 5 minutes because it's not like it's that long. Your presentation will be evaluated on the quality of your presentation materials, the stuff that you actually include in your PowerPoint slides, your presentation style, timing, clarity, vocal tone, and comfort with the material, okay? As well as the quality of your final game demo. There will be a short game demo that you're going to be presenting. Again, one thing to note is this project component replaces a final test in this course, right? And also note that each team member must be present for the presentation to get credit. And that means that not for you to get credit if you and your team, but for them. If they want to get credit, in order for them to get credit, they must be present for the presentation. Okay, they must be physically there, right? So that means labs potentially might be slightly larger than what we've had over the last few weeks, right? So so each team member must be present and accounted for, and be also ready to answer any questions. So I'm going to be asking questions. Alex will be asking questions related to the presentations and the technical work you've done. You may be asked questions around things like your tech, how you did it, what was your approach, and those kind of things during or after the presentation. So be prepared for that. Okay, your ability to answer those will influence your mark. Some mandatory criteria, again, like normal. Assignment 4 clearly is mandatory for this one. You can't do a presentation on something that isn't your work. So if you try and present somebody else's assignment 4, that doesn't make sense. It's got to be your assignment 4 that you worked on with your team. Okay, just to be clear about that. So here are the requirements. Your presentation slide deck. You will need a title page. I'm going to ask you to put together a team name and a little team logo for you guys. This is not a big deal, right? And the name and logo must be original. You could use a team name and logo that you've used in the past if your team members are the same. If you're doing this alone, again, you could have a single logo for yourself. Most people have grouped together. Roles. There's going to be one slide for this, and what I want is a mugshot, so a picture, an image of each member of your group along with their development role and their specific responsibilities during the course of your development for this assignment. So what did they do, these people that were working with you, as an example. And your game concept, although we know what you're making because we've given you specific criteria, but you will kind of describe game elements that you use during this assignment. Things like, for example, what images you use. Why did you choose that background? Why did you choose to make the game the way it is? There's a lot of leeway in terms of what the game could be, right? So if you just submit back assignment or lab 7 to us, I guarantee you that your mark for assignment 4 will be 0 if you just give us back lab 7. Or even any lab that you've kind of created. You must follow the criteria, which is there are game elements, there's animations, there's stuff that we've asked you to do for assignment 4, and those are the kind of things we want you to discuss in your game concept slide. So why did you choose those elements? Like, is it because you wanted to make this, the type of game that you made? What were your influences? Those kind of things. Talk about that a little bit. It's one slide, guys. And then do your game demo. You can insert the game demo video in that slide. Okay, if you really want to. You still must have a separate link for your game demo video when you submit, but you could submit that and press the button, and I'll talk about this in a second. And then your lessons learned, you'll have 2 more slides, a lessons learned slide and a future possibility slide. So after you do the game demo, you've demonstrated your game, you're going to come back and you're going to talk about what did you guys learn when it comes to this particular project when you did decision making. You could be talking about any aspect of the project, things like version control or decision making or pathfinding or anything that you might think about that makes sense, things that you did well, things that you didn't do so well. Okay, that kind of stuff is what you want to talk about. And what if you were going to take this project further, as an example, or maybe or if you're going to use this project as a base for something else that you're doing, or maybe you're using it for game production too or something. Talk about that in the future possibility slide. Things like, hey, guess what? We're actually using this for a lot of this assignment. Again, let's say if you were going to do this for your game production too. Okay, so that's the kind of stuff that we want you to talk about in your slide deck. There's not that many slides for 35 points. So it's like you're looking at, let's see here. So 1, 2, 3, potentially 5 slides. 6 slides? What do you think? If I actually do things the right way. I meant to do this like this, Control B, so that way it would be highlighted. So it's not that many slides, and the great thing about that is I think it just kind of structures your presentation, what you're going to be talking about. That's all it's going to be. It's nothing too crazy. 1, 2, 3, 4, 5, 6 slides total. One slide is just your intro slide, and then you could include a thank you slide as well. Be prepared to answer questions. There will be an answer Q&A period after your presentation. Absolutely. Okay, for everybody. Okay, next part is your presentation recording and gameplay video. So, the idea here is that you'll demonstrate your game on instead of the device simulator in, you're going to demonstrate your game because you're going to build your game, right? Sound for your video must be appropriate level. I must be able to see your screen and the game interface, and a short video should run no more than 10 minutes. I said 10 minutes because sometimes videos take a little longer to adjust than an actual presentation, the live presentation itself. Okay, so that's why I said no more than 10 minutes for this one. The video must be publicly available, but it could be unlisted if you wish. Please do not embed the video only in your submission. So if you're going to embed it in the presentation, like I said up here, to make it easier for you to present, as an example, if you're going to click on that and present your recording as an example, then that's fine, but it should be a separate link as well for us so we can click on the link again and be reminded of the stuff that you've presented. Okay, so that is the 2 parts. 2 parts is your presentation slide deck and then your recording, and then finally your live presentation. So on the day of, this is going to happen during lab time. Okay, so during lab time on Thursday of next week. And Alex and I will probably put together a sign-up sheet for that so we can schedule when you're going to be presenting, okay, during your particular lab times. So there'll be a sign-up sheet that's for everybody. And hopefully we'll be organized enough to get through them all. We do have 2 hours, and hopefully for 2 hours for each lab section. And there should be enough time for us to get through them all. It's not that there's going to be that many groups, as an example, over the entire course of the day to finish this off. However, we also, worst case scenario, if you can't get it off, and that's our fault from a scheduling perspective, we do have your presentation video that we'll be using, and that's why we want you to do both, okay? So you're going to use the presentation materials, a slide deck above that you created, and you will demonstrate your game live, or here's something else you can do. You may choose to share a pre-recorded video of your gameplay. So why? Because a pre-recorded video reduces the chance that you have a technical problem during the presentation day and makes it slightly better, slightly faster. You may use the best presenter from your team. So it's not required for each team member to have a speaking role, okay, for this one. However, they must be present. Okay, that's one thing to note. So why? Because this way you're able to do your presentation and present it well, all that kind of stuff. Be prepared to answer questions. So that's the stuff that those are the requirements, and that adds up to 100%. So again, 35% of the presentation total for your slide deck, 30% for your presentation recording and gameplay video, and 35% for doing it live and answering questions during lab time. Okay, that's where it's going to be. So one thing to note though is if no one shows up from your team during lab time, none of you will get credit. Even if you submit properly on on the Wednesday night and no one shows up for your presentation, you get 0. Okay, so you got to show up to actually do your presentation because it's like your final exam. Okay, in this course, that's what it is here. Okay, so things that you need to submit: your presentation document, and your presentation recording and gameplay video uploaded to your learning management system. So again, notice that this is a separate thing that we're looking for. Okay, so it's not embedded or zipped or anything like that. It's going to be very simple for us to click and see it. Each team member must be present during the presentation day, like we said, and your short video should run, well, I'm going to say 5 to 10 minutes. It's kind of up and down in this case, but 5 to 10 minutes is what we're looking at. I'll change that when I upload it again, 5 to 10 minutes the entire time. And the reason for this is because, again, guys, we want to keep it short and to the point. And the reason for this is because we might have quite a few groups to go through, even if we have 2 hours. Potentially that's, let's say, 6 groups an hour max. And I'm sure that Alex and I have more than 12 groups, as an example, per section, or in around that range, right? So it'll be very tight in terms of getting everything programmed for this to happen properly. So that is what's happening. That's coming up next week. Guys, please don't take this lightly. It's worth 6% of your course grade. So I would ask that you prepare and start thinking about this. If you have multiple team members in your group this week, don't wait to set up the presentation for next week. Start it today, right? It's not that difficult to do. One thing also that I will ask you to do is remember that this is you're in a game programming course, right? And I'm not looking for a business presentation, and neither is Alex. Okay, we're not looking for you to put together a presentation with a PowerPoint theme. Okay, that is not typically as good as something where you customize the presentation materials yourself to make it look like you actually care about the game that you're making and all that kind of stuff. So please do that. Any questions around the final presentation, which is assignment 5, that is going to be due Wednesday and presented on Thursday of next week? Any questions? Again, it should be fairly straightforward. Here's one that I'll come up with a question. What if you just didn't finish your assignment 4? What are you going to do? Right? That is a possibility. Let's say you, because, if you think about your assignment 4, worst case scenario, if you were going to submit it late, could be probably submitted, worst case scenario, late on Wednesday. It's possible. We would still accept it up until Wednesday, right? So what happens if you did that? What happens if you just barely submitted your video, or your assignment 4, or if your assignment 4 was terrible and you weren't happy with it at all? What would happen to your presentation? Well, your presentation would be affected by it, right? Because they're kind of linked. In essence, it's kind of like a 3-part assignment. Assignment part 4, or assignment 4, or assignment 3 would be kind of the foundation or base for your assignment 4. Assignment 4 would actually be your gameplay and your final release. And assignment 5 would really be based on your assignment 3 and 4. So if your assignment 4 is no good, your assignment 5, which is your presentation, will also be no good. And that could be a problem. And that's why we made it 6% of your final grade and not 15% of your final grade, which would be like crazy, right? So, but again, think about this in what would normally happen. We've removed marks this semester from, mid-semester tests, and as well as final tests. So that way you would have more of a practical approach, to submitting your, to be evaluated. Typically in the past, we've had things like true, false, multiple choice type tests and those kind of things, which we removed this semester to make it more practical. And so that when it comes to your, the courses that are coming up for you, some of you in the summer and some of you in September, it should be a little bit better for you in terms of, learnings, as well as things like your coding knowledge and all that stuff. We're trying to push you to go to labs, this entire semester. That's what the whole point of this is. And that's why everything is culminating. So this assignment, just to be clear, there are no extensions on it. So if you don't show up on a Thursday, as an example, you don't submit on the Wednesday, there's no extensions. You can't say, you know what, the submission box closed and it was 12:01 on Thursday morning, and I'm sorry, but I couldn't do it because Blackboard was backed up. And no, it doesn't matter, right? So this from ahead of time. I'm telling you that there are no extensions. So please make sure you submit your stuff properly and on time when it comes to this particular assignment for the evaluation. And it's not like we want to try and be oppressive. That's not the point. It's, again, what we're asking for is so that everyone is ready to present. We're trying to push you so that you're ready to present on Thursday. And if we didn't, then we would have people who weren't ready on Thursday. And that doesn't make any sense, right? So if we're going to do a presentation, then you're going to do the presentation on Thursday. Think about this as an oral exam, guys, about what you did, right? So this is further cementing your knowledge, talking about your code, just like you've been doing throughout the entire semester with your videos, both for your lab and your labs and for your assignments, is going to just make you that much stronger. Okay, so that's what this whole thing is about. Oral kind of or discussion about your code, about your thoughts, and about all those kind of things. Okay, so please, again, don't take this lightly. It's an important part of your learning, and it's going to be due again next Wednesday. Simon says, when and where will the sign-up sheet be for presentations? I'm going to probably announce the sign-up sheet either later this week or early next week, like Monday. And I'll send a note to everybody saying, here's the sign-up sheet. Please sign up for your presentation order. Alex and I have to balance that off because we have to know how many groups are for each one. And the other thing is this: we may decide, if Alex and I may decide to spread it out amongst the three lab sections, even though you may not be part of that. Is if you have time, if you're able to, you have all the links for all the labs, for Zoom, for my labs as well as for Alex's lab. So, again, it might be possible for you to schedule yourself part of any time frame, but we're going to give priority to those people who are part of that particular section. Okay, so if you just feel like presenting early in the morning, but you're part of my sections, well, that Alex will have priority for his team, for his group. Okay, but thank you for asking that, Simon. I will produce that as soon as possible. Okay, and that should include time for Q&A, which is if your presentation takes 5 to 10 minutes and a Q&A takes a few minutes, that means like 12 to 15 minutes per presentation is kind of like max as what we would afford. And we'd have to move on to the next people. Okay. Any other questions around assignment 5? Can you use the A3 GitHub link for A4? You should keep it separate, in my opinion. Which means make a whole new repo. You should have done this already. And the reason for this is because assignment 3 and assignment 4 are separate submissions, even though one is dependent on the other. And I kind of mentioned this earlier this semester as well, Lucas. You should have kept it separate, right? So you can always take your assignment 3, if you're going to base assignment 4 on assignment 3, and copy it into another folder. Keep your hidden Git folder, and then remove your remote connection, and then redo your remote, add a new remote, so you can keep all your commits. That is no problem, but it should be separate GitHub repositories for sure. Any other questions around assignment 3, assignment 4, assignment 5, before we move on to the topic of today? No problem. Okay, so, and nothing on YouTube right now in terms of for the people that are watching. Okay, let's move on to the topic of today. So we talked about assignment 5, with some detail, and now we're going to go into tactical and strategic AI and how that helps you with your assignment 4, right? Because a lot of this stuff we're trying to make it relational, if you will. There's got to be some reason why we're telling you all this stuff. It's not just for the academic reasons of, hey, this is a really cool thing we want you to know about, but rather up until today, it's all related to your course assignments and the things that you're doing. Okay. So we've been looking at several decision techniques over the last few weeks, things like, and different data structures around that. We've talked about state machines. We've talked about decision trees. We've talked about behavior trees. We've talked about goal-oriented behavior. Last week, we talked about utility AI and a bunch of things like that. Those are all techniques that we can use to have an AI make the right decision or something that's appropriate. Okay. So again, one thing to note is that they're all intended for a single character up until now, but they don't try to infer or predict what's going to happen about the entire game state or situation. And we can take some of these limitations that we talked about if you're just thinking about one particular autonomous character, and we can kind of, pool them in or group them together in something called tactics and strategy. Okay. And really what we want to think about is some kind of framework for tactical and strategic reasoning in autonomous characters. And that's why we're bringing this up for this week. So in the model, when it comes to strategy, that is this layer right here inside of our system. So we have decision making, we have movement, we have animation, we have a bunch of things, but right in here is your strategy. How does your AI decide what to do with other AI? What do they do together? How do they combine? And what about not just with other AI, but what do they do when it comes to, they know how to move, they know how to make decisions. How do they pick the right place to seek cover? How do they know what the best place to snipe the character is, from? How do they determine those things? And some of it could be things like pre-scripted. So it could be a pre-scripted movement that's going to happen. So if they're in the particular area, their script takes over, and then they go to cover, or they go to ambush the character. It's almost like a pre-scripted event that could occur, right? That is something that can be done as well, or it can be something a little bit more autonomous. So let's talk about that a little bit. The first part is thinking about waypoint tactics. So we know what a waypoint is. It's a single point in the game. Think about it as an empty game object that is kind of a vector that is in some place in your game state. And we've seen waypoints before. Sometimes we're calling them nodes. Sometimes we're calling them other things. Sometimes in the tile-based game, we got you to make in assignment 2 and even assignment 1, right? When we started getting you to look at those things, especially for pathfinding and those things, we use a tile-based world, right? Those tiles were also nodes. Those tiles were also waypoints in some ways as well, right? And we're asking you to do is, so pathfinding uses nodes, and they use nodes or tiles as intermediate points. So I'm going to get to a final location, and pathfinding is going to use these nodes, from one node to the next node, and we form a node graph or a pathfinding graph in order for us to get from one point to the next point. That's how we do it. And so this is the original use of it, but we can extend this information from pathfinding to allow for decision making. Let's do that. So one thing is we can use waypoints in pathfinding, and they represent nodes in the graph, things like connections, quantization regions. So going from world space to games to the grid space, from grid space localization, from grid space to world space. And they also might represent costs. We talked about using a cost function, which we'll talk about again. Things like some kind of heuristic evaluation of how long or how the distance between your start point and the target of where you're going. But when it comes to using waypoints tactically, we need more data for the nodes, right? We need to kind of fill them with information about what they could be doing differently, and maybe that each node might have a specific role other than just a point from here to there. So again, they can be used to describe tactical locations, and sometimes we call these rally points as well. It could be a safe location for the autonomous character, and in assignment 4, we've given you a safe location. We've asked you to perform an action like move behind cover, right? Wait behind cover. We've asked you to do those 2 actions. And so these tactical locations we're giving you, there's 2 ways to do them, and we're going to talk about them. One way is to do them automatically, and the other one is to, kind of add information to that particular position to tell the autonomous character that is indeed a cover point. We haven't done that in lab, but what you could do right now in our lab is it gives you the ability to move all your obstacles around and those kind of things, right? For the lab 7, Alex added things like a buffer zone for obstacles. He added things like, where we can move everything around, right? But in your game, the stuff that you're making for assignment 4, it does not have to be that way. You don't have to make it so that I can move obstacles around. We didn't ask you for that. We asked you to make a map and have some kind of nodes that are underneath the map, right? And those underpinning nodes are the things that you're going to map on top of. You're going to have a layer, which is a texture layer that we're going to see, something that represents something that our user interface or feedback for the player, right? The player is going to be able to look at your game world and go, oh, I see that's a mountain. That is an obstacle. I have to go around it, okay? That's the feedback for them. But underlying that, as an example, there's a node. And that node can be a very simple node, like we've given you already, or it could be some kind of tactical node, where the node itself has more information, okay? Where the node knows, hey, this is a cover node. This is a place where you want to send an enemy, potentially, or one of the autonomous characters, to go there and hide, right? Or snipe the character, or do whatever they're going to do, right? You could do it that way as well. And again, that waypoint node, okay, or that place, that cover node that your autonomous character might go to, it might be a decision, a choice, right? Example, let's say you plot in your game world, you have a map, and you've created a map where there's a clump of trees or some kind of rock or something like that, and if you position, if your autonomous character is patrolling and then they see the character, they might go behind that rock where they can kind of pop out, snipe, come back into cover, and so on. Those kind of things are, or if they get hit, they can run to the closest cover point, not necessarily to the closest node, right? So that may make more sense. But we have to talk about this if we're going to do it this way, because again, it has to be contextual. What if there's no cover at that time because your the player's chasing you, the autonomous character? If there's no cover, then that cover point becomes eliminated out of the choice of decision points that the autonomous character is going to make. And what I mean by that is, okay, you're playing the game and you have all these, you're the player and you have all these autonomous characters. You have two types that we've asked you to make for assignment 4. One is a ranged combat enemy, and the other one is a close combat enemy. And the ranged combat enemy has this ability for them to go behind cover. That's the one we're talking about, and snipe you. Coming out of cover and then snipe you and come back into cover, right? So that idea of being able to do that, as an example, what if there's no cover anymore because the character comes around the rock? Well, then that point is eliminated, so that the autonomous character has to run away. They have to move from there, right? So that's the idea, and the idea of rally points or marking a safe location on the map, safe locations on your in your assignment 4 is not a bad idea for improving some of the decisions that your AI is going to make. Like, where am I going to go? We've given you, the closest place that has cover, right? The closest location, but you could actually, with some careful level design, you could create points of cover for your autonomous characters. And so when you're making your A4, it's a little easier than for them to automatically guess where they're going to go, as an example. So this idea is the same idea that we use for making real-world military planning. You look at the map, as an example, and the map itself goes, okay, well, the player is probably going to come here, right? So I'm going to, when it comes to a rally point or a safe place, I'm going to go here, right? That kind of thing. Almost like a safe withdrawal point. We've talked about one of the states that you can have for your autonomous character is to flee. That's one of the states if they get hit. And in another scenario, we could have made them so that they flee to some kind of base. We didn't do that with you, but we could have said go back to base and heal. That's your step, right? Where the character, your autonomous character, can't enter the base, right? And maybe one we could have made is, it'd be more complicated, by the way, that's why we didn't do it. If your autonomous character goes to the base, then your player can't enter that base. They have no access, something like that. But again, that is just another idea that we could have used, and that could have been their safe withdrawal point. Here, there isn't anything like that. Their safe withdrawal point is off the screen, okay? So, again, a lot of times, we use tactical locations to represent defensive locations or cover points. And that's what we're going to get you to do for your assignment 4. So again, if you have a level designer, and again, you guys in many ways, you're not just programmers for this assignment, but you're also level designers. We've asked you to lay out your map and make an interesting map, is what we said, right, of how it would look. And you can mark places like, let's say, for example, you wanted to create barrels or some kind of, debris, rocks, whatever you wanted, whatever makes sense for the context of your game, where that might make a good cover point, right? Then, when an autonomous character engages you, the player, it will move to the nearest cover point in order to provide itself with some kind of shelter when it comes, especially if it's a ranged combat. That's the one we want. The ranged combat enemy. It's going to move there. It could move to kind of just outside of cover, and then start firing at the character. It's really depending on your level design, right? But in other games, you might have other types of tactical positions, like a sniper location, which are really important for things like squad-based shooters, right? So, your autonomous character in another game might move to a sniper location. But what are sniper locations, right? What are locations suitable for snipers? They have to have two things. They have to have some kind of cover and access to the enemy, which is like visibility. We'll talk about visibility in a few slides. So there's a bunch of different ways of representing tactical information for nodes, right? We're going to pass some of those information, and we're going to create waypoints, or cover points, or shadow points, or ambush points, or whatever you want to call them, right? And there's a lot of ways to represent those things. So for each one, there's some kind of tactical location in the game, and sometimes they're positive or negative when it comes to a particular tactic that the autonomous AI wants to get into. Okay, and let's talk about those in a bit. So again, when we look at things like waypoints, we have a large number of waypoints in, as an example, in the game world. Right now, we've given you 300. All right, typically. You don't have to use all of them, obviously, because there might be some tiles or layers or whatever that you might decide not to use. You might use that as impassable, right, as an example. But each one of those could have some kind of tactical quality. So another layer, another piece of data that you're going to hold for each of the waypoints or nodes in your game, okay? So it's not just for pathfinding, but also for other things like we talked about. So again, when it comes to pathfinding, though, and when I'm thinking about pathfinding and tactical information maybe not go together a little bit. Here's some example of a graph that we can look at, right? Where we have a game world, and in this particular image, the author, what they've done is they selected areas that are tactical. So for example, here is an area here, the dot represents some kind of cover or shadow. So they're in shadow, which means they're tough to see in the game world, right? And that could be tough for you as a player too. If they're in shadow, you can't see them. There's no light on them, as an example, and then they're completely black. They're blacked out, or they're in the shadow. As soon as they step out of the shadow, that's when you can see them. There's lots of ways to represent that in a 2D world. You could use dynamic lighting, and you could also use just a very dark area where the autonomous character is obscured. So it's kind of a neat way of doing it. So this is just cover and shadow, but there's maybe not a great opportunity for sniping. Whereas this place right here might be great for both being in shadow and sniping, because you have maybe some access to a couple of corridors, right? And this might be something like sniping, cover, and shadow, where you can pop up, snipe over the barrels. Let's say if these are barrels, you're in shadow and you're in cover. You're in a good cover position as well, right? So this one, you're in the open, right? So there's light around here, but you could be behind cover. And this one, you have cover as well, behind a wall, let's say, right? So there's like a bunch of different waypoints here that we've kind of described, or nodes, with different cover and sniping and shadow qualities, all right? So those are the things that we've talked about: cover points, shadow points, sniping points, or it could be all three. For example, this one, okay? So again, so one thing is that we want to be, kind of predefine a bunch of some kind of tactics. Again, these things that we've talked about: sniping, shadow, cover, and it supports, the autonomous character to have more of an interesting and intelligent behavior, as opposed to, well, they're just going to go to the nearest point. That's not always the best point, and we'll talk about that in a bit as well. So when we think about this, if I take a look at snipers, let's just look at a sniper location, then we can decompose, kind of the two tactics into two primitive tactical requirements. I need cover and I need view of the enemy. Those are tactical requirements, or primitive tactics, if you will, right? And what we can do is we can compose or compound, these tactics into something that's a little more complex. Sniper, right? So view of the enemy might be a tactic. I want view of the enemy. Okay, I want line of sight. That's what that means. Okay, and I also want cover. To have cover and line of sight, well, in a 2D game, that might mean that I'm not crouched. Maybe we could have made a tactic for you, or some kind of a mechanic that we say that your autonomous character could also crouch behind cover, right? And if they crouch behind cover, because cover has some kind of height limit or whatever, and we could have made it so that your autonomous character could be seen above cover, as an example. Well, we didn't do that, of course, because that's more complex to do, but that is definitely something that could be included in the game, right? It works a lot better for 3D games, I find, when we kind of think about this, crouching and then showing yourself. But shadows can work really great even in 2D. So again, cover and view of the enemy, those are the two things. So, and when it comes to view of the enemy, we want to think about things like high visibility points when it comes to, where there's a great visibility point for the autonomous character, but also provide some cover. So where they can pop out, as an example, and maybe there's even a short wall that your character, your player can't get by, as an example. Maybe there's a gap in the wall where the autonomous character can kind of pop out, shoot, and then go back into cover, but your player can't go through that gap. It's too big, or something. There's a lot of ways of kind of doing level design to support those kind of positions. So this is like the idea of combining those two little primitive tactics creates this compound tactical quality, all right, that we want for different locations. So again, if we're looking for good locations to mount an ambush, so that was the sniper idea, we could look for exposed locations, that's a tactic, and good hiding places, another tactic. So we get those two tactics, and then we kind of combine them to create a compound tactic, all right, something that looks, has both of those qualities, right? So a good example of that is good hiding places are a compound tactic themselves, because that means that they have good cover and shadow. So here, as an example, that will be a good hiding place, right? And you also want exposed locations. So here's an example where there's an exposed location out in the open, and there's plenty of light. You're in shadow, your autonomous character's in shadow, but your player is going to come somewhere in here. So they're going to wait in there. Your player can't see them. They're in shadow, right, as an example. That could be a game mechanic where the player unless the player investigates the shadow, like actually looks towards there, shines a light or something like that. Even in a 2D game, that could be very interesting to do that kind of stuff. Then they're exposed and they have the ability to be ambushed. And if they get ambushed, if they get shot from cover, maybe the damage that the enemy does more, almost like a surprise attack, an ambush, right? And if you get surprised, maybe it's a one-shot kill. Maybe you come into a place, you haven't checked cover, you didn't do your work, your due diligence, and then your player gets shot, right? Guys, that happens a lot in games. I'm just thinking things like games like Dark Souls, or even Bloodborne. Where you're walking around, you don't check behind a corner, and all of a sudden you get clocked by a guy with an axe. In Bloodborne, and it's pretty scary too. It can be pretty scary. You didn't check. You didn't anticipate someone was coming out there, and it's a one-shot kill. You're done, right? Or might be anyway, depending on your character level. But the idea here is that we want a quality location depending on the tactic, whatever the tactic that your autonomous character is looking for, right? So if they're a type of sniping close combat enemy, range combat enemy, then that's the tactical location or waypoint in your graph, in your world, that they're going to look for. It's not just about cover; it's also about shadow, right? Something else. And so that's something that they might want to do. So here we have cover, but there's, and you have an exposed position, but you don't really have a good hiding spot because you want both cover and shadow, right? Here might be a pretty good location where you have cover, shadow, and you have a sniping location. We don't care about maybe the sniping, but you have both cover and shadow, and there's also an exposed area where a corridor where the player might come, right, as an example, okay? So when we think about this, we want to we've just described these things in kind of some of these isolated locations, right? There's no information as to whether one waypoint can be reached from another waypoint. We haven't talked about connecting waypoints in any way, right? So really, when we talk about them, waypoints are really like nodes in a pathfinding graph, which we can use as tactical locations. These are different things than what we've talked about before. But even if we aren't using some kind of pathfinding graph, we can still link together tactical locations to give access to more sophisticated compound tactics, things that we've talked about so far. Let's suppose that we're looking for somewhere that provides a good location to mount a hit and run type of attack, right? So we have a few different locations, location A, location B, and location C, right? And let's suppose location A is on a balcony somewhere where you have to go up a stairs. There's a bit of an elevation, right? So location A is pretty good because it has good visibility to the entire room, right? And it's a good quantity for an attack spot, a quality, because you don't necessarily have cover, but you might have access, right, as an example. And what I mean by that is you could kind of leave in this direction or in this direction, as an example. B, if we look at B in this anteroom, right, we might have another good location for a hit and run, where if you have a player that comes down kind of in here, right, as an example, or anywhere in this exposed area, they could kind of like, do a hit, and then the autonomous character can run away. And this hit and run type tactic is very, very common, where you, even in real life, where, you kind of snipe away and then you run into the next room and you hide, and you might kind of, transition from one room to the other room, your autonomous character, and then the fight continues, which makes it for very interesting combat tactics inside of a building. Okay, but the balcony is truly the better location when it comes to a hit and run, because it has 3 exits. You could exit towards the room, you could exit out this way, or you can exit out that way. Again, one things we also want is so exit or access is one of the primitive tactics, primitive requirements. The other one is good visibility. I want to be able to have visibility to be able to snipe the character or whatever. And when we look at those two things, then we can do this topological analysis of the map. So we look at the topology of the map itself, and it talks about the structure of the level by looking at the properties of a waypoint graph, or a tactical location graph, if you will, right? And what we want to try and do is we want to try and connect all these tactical positions and try and do this in a way that makes logical sense, right? Not just for the autonomous character to beat up the player, but rather so that it makes sense for the game world and your story, right? So it has to have context. You're not going to just put barrels inside of a building for no reason. There's got to be a reason why barrels are inside of a building, especially if it's a house, right? If it's a some kind of post-apocalyptic game, then barrels inside of a house might be okay, and maybe there's no roof on the house as well, right? That might make sense. But if you're talking about a regular neighborhood and there's a barrel inside of a house, that's not normal, right? Is there a barrel in the backyard where they do some burning of wood or something like that? Maybe, and that might be some kind of thing that the autonomous character can use as cover, or garbage cans or something like that where they can hide. Those things make sense. So it has to be both contextual and tactical. It can't just be some random things that you want to put in your level, or it doesn't make sense. It'll break the immersion of the player in your game, and that will take away some of the fun. All right, so this topological analysis, it can be performed using pathfinding. We can use the pathfinding graph, or we can use these tactical waypoints. It does require connections between waypoints. We need to know, what waypoints are connected to other ones, right? So a good example of that is in the original A2, assignment 2 that we got you to do, we used the tile-based grid, and in the tile-based grid, we had 4 neighbors. We only allowed you to have 4 neighbors. But remember that with waypoints or even nodes that you have in your assignment 4, there's nothing that's stopping you from connecting, the nodes together, where you can have 8 nodes connected, to do your pathfinding. One of the things that we've asked you to do in assignment 4 is move to, to cover, move to, to a close combat range, move to, whenever we say move to, there's lots of ways to move. You can use using, some kind of steering behaviors. You can also move using pathfinding. It's really up to you. And you can combine steering behaviors and pathfinding to create a much more realistic movement than if you use just one. Okay, so these are all the things that we've asked you to put together from all the stuff that we've talked about this entire semester. We haven't forced you to do it for assignment 4, but there's some really great ideas there in terms of how you can do it. So so that's the thing. We want to make these connections. And one of the biggest problems are, it might get complicated depending on how dense the waypoints are. So if you have a lot of waypoints in your graph, in our case, we have our map that we've given you for Lab 7 is very dense, or not very dense, but dense. It has a lot of waypoints. We have 300 waypoints potentially, or 300 nodes that we might have for the entire game world. That might be a lot of nodes for you, right? To start thinking about what the tactical information we're going to give to each of these nodes. It's a lot, right? And you can do it automatically, right? And that might be something that comes up. People talk about automatic topological analysis. But honestly, a lot of this is done manually, right? So you kind of map your graph and you go through and you go, okay, you know what? Waypoint number 17, that is going to be a place where our autonomous character is going to be able to hide and snipe and has good cover. It has shadow. It has whatever, all the qualities you might want. Okay. So this manual topological analysis might be something when you're creating a level, doing level design, that might help you when it comes to how your autonomous characters act and respond. So one thing we can also talk about is something called continuous tactics. And continuous tactics is, certainly we can use compound tactics that are, do I have cover? True. Do I have, some kind of visibility? True. Those are, Booleans we could use. Well, we can move away from that and we can use a numerical value to represent the quality of that particular tactical location for a specific tactic. Not a compound tactic itself, not for example, sniper, but rather for snipering, you need two things. You need, like I said, some kind of cover and visibility at the very least. Shadow would be even better, right? So what you can do is you can rate these locations with some kind of floating point number from 0 to 1, where 1 is 100% or maximum amount of cover, shadow, visibility, whatever you want to call it, as an example, and or something lower. And if your character, if you wanted to make it so that it's less deterministic, right, and you wanted to make it move kind of more naturally, so it's going to find cover, and you haven't done it, you haven't kind of marked cover spots in the level, maybe what you want to do is create a, kind of a value, a data value, floating point number for some of the waypoints where that area might have 90% cover, if it's behind a certain point, or 80% cover, give it a value. And then what if other places have only 60% cover, and the amount of cover might be determined automatically also. For example, how many waypoints, other nodes or whatever, or waypoints can see that point? Is there only 1 point, 2 points, 3 points? It might be some kind of, you might have an algorithm or whatever that determines this, as an example. So let's say, if I have cover from, out of 8 possible connections, 8 possible neighboring waypoints, I have cover from 4 of them, then maybe my cover value is 50%, as an example. And then the higher cover values are the ones that, your autonomous characters will go for compared to the lower ones, unless they don't have a choice, okay? So that is, the way it would work. So let's also talk about what we just kind of talked about before, which is context sensitivity, right? So hiding behind a barrel, might produce cover, only if the autonomous character is crouched. Maybe because, if it's a barrel. Because if you have an autonomous character and a barrel is probably not going to be floor to ceiling, that's typically not how it works, right? Barrel might come up to your waist or whatever, or maybe a little bit higher, so that means if you're standing behind a barrel, how much cover do you have? And that leads us down to another discussion, a discussion that we talk about even in tabletop role-playing games and other kinds of tactical games, like there's different kinds of cover. There's partial cover, as an example, and then there's full cover, right? So in our game for assignment 4, when you're in cover, you're in full cover. We don't have anything like partial cover. Partial cover means that you'll get some resistance versus attacks, or line of sight attacks might miss some of the time, as an example, or whatever, some kind of armor value that your autonomous character gets just because you're in partial cover. And partial cover might be something like a barrel where half your body is covered, as an example. Or it might be something like, you're in a bunch of ruins, and there's a lot of broken windows, and there's a lot of holes inside of the wall, and there's partial line of sight. You get some line of sight points, but you don't have a lot of them. Again, depending on how many you have and how much of your body is exposed, this is depending on the game you're playing, you might have either partial cover or full cover, right? Here, we're not even talking about that. We're just saying either you have cover or you don't, right? But to keep this context sensitivity alive, the other thing to think about is if a player runs around a rock where an autonomous character is hiding behind, there's no more cover. So there's got to be a way of the game understanding that when the player has a waypoint that is visible, cover value becomes 0. All right, so that way the autonomous character either has to flee or attack or do something. Okay? So that's the kind of stuff that we talk about when it comes to context sensitivity. Let's continue with this idea even more. So there's a couple of ideas for implementing context sensitivity. One of them is we could have multiple values for each waypoint. Okay? And the other one is we could use only one state per waypoint. Let's talk about those two things. If I said multiple values, imagine if cover points shown on this image right here, with their quality of cover in each of the 4 directions. So I have north, south, east, and west. Okay, so what kind of cover do I have in each of these directions, right? And the autonomous character works out the direction to each of the enemies and determines that it needs cover from the south and east directions. So here's my character needing cover. I have something to the east and I have an enemy to the south, as an example. And when we look at the cover point B has protection from the enemy in the south, because that's 1, but it has no protection for the enemy in the east, which is more like northeast, right? So because of that, and there's nothing in the north and nothing in the east, the autonomous character might choose to go to cover point A, because cover point A has no visibility from, as an example, either enemy. And by the way, this also works when we've been talking about autonomous characters as enemies to the player for assignment 4, but they also could be non-player characters, as an example, that work for you or with you, right? In kind of some kind of cooperation, a co-op mode, right? So that's definitely one way of doing it. We can have multiple values for the type of cover. We can do some, kind of what kind of cover we have from different waypoints, and then we can kind of decide it that way. The other one we can do is we can use one state for a waypoint, and the one state we can use is something like line of sight. So it kind of works out to be the same answer, right? But line of sight it kind of works like this, right? So cover point A does not have a line of sight to either of the enemies, right? So cover point A might be the best location because there's no line of sight, right? That's cover, right? Which is what we've kind of talked about for you for assignment 4, right? We said if there's no line of sight, that is where you want to go to cover. If there's partial line of sight, that means there's line of sight to one of the enemies, then it's clear that cover point B is inferior to cover point A when it comes to finding a cover for the autonomous character from 2 enemies. Okay, does that make sense? So that is your idea of context sensitivity. How do I make it so that I find the best cover based on the situation that we're in? Let's talk about simple tactical movement as well. And again, in most cases, the decision-making process determines the tactical location that we want to go to or use and its needs. And we can actually query the tactical points in the immediate vicinity. So what is the immediate vicinity? Well, we can also talk about the character having a radius, right? So remember when I talked earlier this semester, we discussed things like flocking. And when we decided to talk about flocking, we said that, a Boyd may not care so much about another Boyd, another autonomous character, at the other end of the world. They don't care about that. They only care about, autonomous characters or situations near them in the immediate vicinity. How do I know what the immediate vicinity is? We could have a radius. Things within a specific radius or distance, right? That's my immediate vicinity. So I only care about tactical waypoints in the immediate vicinity, somewhere I can get to within a reasonable time frame, right? For example, I want there's a couple of options, right? I want a suitable location. What is a suitable location for, I want to decide one to use that's the target for its movement, right? So I want to kind of move to that location. It could be simply the nearest suitable location, so something that is the nearest point, right? Remember, keeping context sensitivity in mind, the nearest suitable location, we have to determine first what is a suitable location, right? So let's for example, let's say there's no line of sight with the enemy, which is the player in this case, right? And let's go to the nearest place. Or the other one might be a suitable location with the highest numeric value. Maybe it offers other things. So the autonomous character you might have might be a very simple guard, right, as an example. And all they care about is getting to the closest cover. I just want to get to the closest cover place. Or someone else, there might be another autonomous type character that has maybe a higher level, maybe a captain of the guard. And they have different ideas. Maybe there's a suitable strategic location where not only do they have cover, but they have access to the alarm. So I can set the alarm off, right? And so that I'm going to bring forth more guards from different exits, to the player. So it's going to cause the player to have a much more difficult time, right? So that is different kinds of ways of performing that, and you can have either one or both of these kind of things happening. I want the nearest suitable location with the highest numeric measure, whatever that numeric measure is, based on the tactics that I need. I want to be able to snipe the character, and I want to be in cover. And what is my sniping value? Do I have points of visibility around that waypoint? Yes or no? What do I rate it out of a 0 to 1, where 1 is 100% awesome in terms of visibility, and 0 has no visibility, right? What is the best location? Okay. So we can think about this, right? And we can add the tactical information to the decision-making algorithm. So if I'm using a decision tree, like in this case, we might make a decision based on the nearest cover point. Here's an example. Let's follow this decision tree. And decision trees are something that you're potentially using for your assignment 4 too. Although I have to mention that we never said to you, you must use a decision tree for your assignment 4. If you decided, as an example, to use a state machine, and you did all the same stuff in assignment 4 with the state machine, all the power to you, right? If that's what you want to do. Or if you wanted to use a behavior tree or a mix of a behavior tree and a state machine, as an example, as opposed to a decision tree that we've shown you in lab 7, you're totally open to do that. There's nothing that says in any of the assignment requirements that you must have a one type of data structure or another in order for your AI, the AI and the AIs in the game to perform a decision, to make a decision. Nothing like that, because we're giving you different options and we want you to have the ability for you to do that. So here's a decision tree, and you can say something like, okay, do I have ammo? And let's suppose we'll say that we'll go on the no track, and typically I like to flip this around where no's are on the left-hand side and yeses are on the right-hand side. Here it's kind of a mix. The authors kind of put things together. So let's go no, I don't have ammo. Okay, good. Is there cover nearby? No, well then reload. I don't have ammo, so I must reload. Is there cover nearby? Well, yeah, well then take cover, because taking cover might be, a decision we want to make, as opposed to just reloading. And this is kind of very similar to what we've got you to do in your assignment 4, right? What if I have ammo, right? Then, okay, cool. Can I see the enemy? So do I have line of sight? That's what that means. If I don't have line of sight, patrol, right? Which is kind of very similar to what we've asked you to do, hunt the enemy, right? If I do have line of sight, okay, cool. Is the cover nearby, right? Is there cover? Yes, take cover, right? If there's no cover, well, shoot, attack, right? Because there's no cover anyway. You might as well attack it either way, right? So this is another decision tree that could be used, not necessarily in our scenario, because we've given you strict kind of instructions on what we want your autonomous character to do. But this is an idea of where we can include things like cover inside of your decision-making process. So again, one thing to note is that distance isn't the only factor when taking into account, or making a decision, right? So here's an example. You have an autonomous character, and the distance between, as an example, let's just draw this out here. The distance from, here to here, right, is greater than the distance from here to here, right? And if we looked at this atomically, so we didn't care about walls or any obstacles or whatever, right? Then when we're thinking about distance as in heuristic distance, right? If I'm or some kind of like Euclidean distance as the crow flies, not using pathfinding in any way, then this would be a bad decision, guys, to come here, because the actual distance to this point is, well, they would have to go all the way to here, turn a corner, and then come back this way. This is the actual distance, right? Whereas, the distance for this one might be something like, well, I'm going to go to here and then to there. That might be a much shorter distance than, even though from a distance perspective, as the crow flies, this is something that is shorter and this is farther. But from a tactics perspective, when it comes to pathfinding, you can clearly see that this distance is much greater than this one. Okay, so how do you come up with that? Part of it is careful level design, where you don't want to make walls too thin, number one. If you're not going to use pathfinding the way we're talking about it, right? If you're going to use line of sight as an example, and you're going to say, well, which one is closer, right? So, taking distance into as a factor just by itself is not really, not a good idea, all right, is what we're saying. Okay, whereas if you combine distance with pathfinding, you would see that this is actually longer to go around the corner, right? So when it comes to cover points, let's talk about cover points for a second, because this is what your assignment 4 is partially about, right? The quality of a cover point is calculated by testing how many different incoming attacks might succeed, or how much line of sight do you have, right? So we can run a complete simulation. We could do that. But it is normally easy to approximate an attack by line of sight test, like a raycast, right, through the level geometry. So how far can I see? One thing we didn't say in the game, in your assignment 4, is that we never specified that your enemies have a line of sight range. We never said that. Nothing in assignment 4 tells you that. We did that in lab 7. We gave your enemies range, so they couldn't see beyond a certain point. But in the assignment 4, there's nothing like that. Your enemies should be able to see from one side of the level to the other, right? Theoretically, if they can see the player, they need to get close enough to hit the player. That's a different thing. Maybe their weapon only has a certain range. That's a different thing than, as an example, their actual line of sight. I can see you, but my attack range might be a different value. So maybe my gun can only fire a certain range. Let's say something like, if you have a handgun, something like 20 meters might be something where your gun is somewhat accurate. Beyond 20 meters or whatever like that, then that might be too far, or whatever. And whatever meters are or points in the game world, right? And we're just making this up here. I'm not saying I'm a gun expert by any means. So again, we can, for each attack, we can start by selecting a location. So you select a waypoint in the vicinity of the candidate, right? For the cover point itself. And usually which will be, in the same or adjoining room, to the cover point, if I'm looking at that particular cover point. And then we can cast a ray toward the candidate cover point from different locations. And once we do that, we can keep track of the proportion of the rays that hit the target, how many of them hit the target, to create that measure, whatever that is. So like I said to you before, if I have 300 waypoints or 300 path nodes, and we create a room, you created an area where there's obstacles or whatever, how many obstacles within a certain radius of a particular path node, have line of sight? How many, right? And you can come up with a ratio or a number, and that number is what kind of quality that cover has. You can come up with a number like that. Okay. Similarly for visibility, all right, points of visibility, right? Because you want to have a point of visibility when it comes to sniping and stuff like that too. Or I'm going to pop out of cover and I want points of visibility. Well, maybe there's going to be better points of visibility instead of randomly, your autonomous character randomly selecting a point. of visibility or coming to the first point of visibility, they're going to come to a better point of visibility where the autonomous character can see more areas of the level. So you can actually create a rating system for each of the points in your game world, both on cover and visibility. And once you have that, then think about your decision tree you're making for assignment 4, where you're moving to cover and coming out of cover again. Where do you want the autonomous character to come out of cover? You want them to come out of cover where they have the most visibility so they can attack the player better, not just outside of cover where they barely can see the player and nothing else. The player moves around the corner, then they've lost line of sight again. They got to go and find line of sight. And that's not as good as, well, guess what? If I move here, I can see down this corridor and down this corridor and over here, right, as an example. And instead of just seeing this like smaller range of, smaller points of visibility. And it might look something like this. So example, you might have a region, things to think about having good cover and visibility, right? So here you have a visibility arc, right? You can see all this stuff, right? And here there's no visibility. So you have no visibility over here and none over there. And here is a region of full cover, right? Because here you can't see anybody, right? So because the autonomous character can't see you there, anything that's over here is under full cover. Same thing over here. Where remember we talked about full and partial cover. Over here, you have some visibility, but you may not be able to fire over there so easily, as an example. So we can consider this an area of partial cover or lesser cover than, than this region over here. Whereas this region in here would have absolutely no cover because you can fire from any part of the autonomous character. So this is the good place to have if the character comes in, if you can lure a character here, a player, as an example, with your level design, that might be really great for the autonomous character. Because, hey, if the player is going to come here and you make them so that they have to come here, you put in some kind of debris, maybe you design the level so they must come into here. It's almost like it becomes a shooting gallery for the autonomous character, which is exactly what you want. You want to give your player a difficult time, not impossible, but a difficult time where they have tactics to overcome from the enemy. And it can be very interesting. You can make the enemy feel very intelligent, or your levels seem, to be carefully crafted as opposed to randomly put together. Let's talk about tactical pathfinding a little bit. So far we've talked about, a couple of things. We've said, hey, this is a cover point. This is a point of visibility. Maybe this is a point of shadow. How do we do tactical pathfinding now? When we've talked about tactical decision making, but what about pathfinding? Pathfinding uses a pathfinding algorithm, some kind of distance and time value or whatever, and the shortest cost and all that kind of stuff. How do we incorporate tactics with pathfinding as well? So we want to kind of combine tactical analysis, with the stuff that you learned in the first half of semester, and kind of put that together, right? So when we make a move, we want to move taking account your tactical surroundings now, not just surroundings based on the closest point or the shortest path. We don't care about that only anymore. We want you, maybe what if I wanted the autonomous character to find the shortest path while they have cover, the most cover, when they're moving from one place to the other. So they pop out of cover, they run from cover point to cover point, as an example, and they want to take that path as opposed to the shortest path, which would be exposed out in the open, right? Your autonomous character in real life, if it was a real life person and they were under fire, like there was an alarm condition, right? They would not do that. I wouldn't go in cover or out in the open. If I knew people were sniping at me, I would stay behind cover and run from one point to the other, right? Or dive or whatever it's going to be. That's the kind of thing that you want them to do. And we need to modify the cost function in order for us to do that. Let's take a look at that cost function. So again, when we talk about cost, the costs are moving along a connection in the graph should be based on both distance, time, depending on the kind of on the context of your game world, and how tactically sensible that maneuver is. So both things now, all right? So the cost of a connection is given by the following formula, which is a little bit different than what we've seen before. So cost then is distance of the connection, so how far it is, or time, or some other non-tactical class function, something that you want to, give the player, the character. WI, or the initial weighting factor, whatever that initial weighting factor is, right? For each tactic supported in the game, right? So that's what the WI is, right? And then capital T I is the initial tactical quality of that particular of the connection, whatever that connection is. Again, for each tactic, and I is the number of tactics. So we say that the total cost function is equal to the distance from the connection plus the sum of all tactics, right? Where we have both taking into account the weighting factor and the tactical quality of of that particular location. Okay, so that's what the cost function would look like now. And again, how do we weight things? We can return to that, but basically what we're doing is when it comes to weighting factors or tactical quality, things that I would think about again are things like, am I using a numeric way of making that decision? Am I rating the tactical, the compound tactic, both for cover and visibility? Is that what I want to do? It really depends on my goal. Like, what is the goal of your autonomous character? If your autonomous character cares about, is a stealth kind of character and wants to get the drop on your player every single time, then shadows might be the way to go. I want to pop from one shadow to the other. I want to get there when the player's not even looking at me. And we can actually see that where the player themselves have they have a facing, if you will. So if the player is facing in a particular direction, maybe the shadows become lesser. They become almost like, we can make a mechanic like that, let's say in a game, where you have more of a transparency for the shadows, as opposed to being absolutely dark, right? Whereas if they're not looking at you at all, they have zero chance to see you. So you're completely blocked. You're invisible when it comes to being behind that that cover as an autonomous character. And that's kind of a neat thing. So you can create that mechanic for your game, almost like that shadow cover tactic mechanic. One other thing is when we convert location-based information into connection-based information, we normally do some kind of averaging. I want to average the tactical quality, and that's where the weighting comes into play, of each of the locations that the connection connects to, right? That's what we want. So what is that average tactical quality? In other words, if I have a couple of different tactics for that particular waypoint, and let's talk about them again, cover. We say, what's the cover value? The cover value might be 0.5. Okay, what's the visibility value, the sniping value? As an example, well, the sniping value might be 0.7. Okay, so it's not so much cover, but I got better sniping. Well, guess what? That tactical quality for that particular location is 0.6. As an example. We might also determine that a location and how close it is to cover, how close it is to the next available like full cover location. We might give it some other values that we want to kind of add in there to create some kind of pattern or more complex, logic that we want to use in order for us to select that. So we have some kind of average tactical quality of that location. But the problem with that is sometimes this can produce some really weird data. So here's an example of, I've come into this location here and I can go into one place or the other. That might cause me some issues because both places might have cover, right? As an example. So which way do I go, right? That could present an issue, right? Is what I'm saying. So one thing we have to do is we have to recall we used different kinds of heuristic for pathfinding, and one of the heuristics we used was Manhattan distance. Another one was Euclidean distance, and there's a bunch of other heuristics that are out there as well that you can use. And what it is just an estimate of the distance, the total path length between where you are right now, the start, and the goal, the target. Okay, as an example, and it should always return less. Distance, the actual heuristic itself should be less distance than the actual shortest path length, because really what we're doing is, okay, I'm kind of calculating the distance from, my particular path node or waypoint to the target, and it could be as the crow flies, Euclidean distance, or some kind of Manhattan distance, but it's to still be shorter than the actual path in order for it to work properly. So, and that way the character will have easier time making a decision. So, so again, we thought about that any actual path will be at least as long as the Euclidean distance and will usually be longer. That's what we want to try and do if we're going to use Euclidean distance. With tactical pathfinding, though, we are no longer using the distance as the cost. We have to also think about the tactical quality. So what do we do with Euclidean distance? We can't use Euclidean distance. We can't use just Manhattan distance. We got to make our own heuristic, which is what this is saying here. And the most common graph for tactical pathfinding is actually the tile-based or grid-based graph, which we gave you, in assignment 2. We said, that might be the better way to do it. Why? Because each tile in the grid would have specific types of quality, tactical quality, not just the distance value. Now, there's nothing that stops you from having that amount of dense tiles, just like we have right now in Lab 7, right? In Lab 7, we have 300 path nodes. If you consider each of those path nodes a pathfinding node, right, or a waypoint, and if you connected each node to all of its neighbors, not like how we did it in assignment 2, so it would have potentially 8 neighbors as opposed to 4, right? Then you can do really detailed pathfinding, and you can give it some really great information, right? For example, what is the cover quality? What is the sniping quality? What is the whatever quality you want for that particular location to make so that your AI can make more sensible, logical, contextual decisions. Yeah, that's the idea behind it. All right. Any questions around tactical AI? Right. So we talked so far about how to move things, and there's a lot more to this. We could have gone further and talked about other things like coordinated attacks. How did that work? And one of the biggest problems with coordinating attacks is when you're coordinating with a player, right? So you have a bunch of non-player characters. Let's say they're part of your tribe or your squad or whatever. They're non-player characters. You're the player, and the squad wants to go one way because their tactics are telling them that, you know what, I want to stay in cover, so I'm going to go over here. But the player is actually moving out of cover in an exposed position because maybe they're just not as good as the AI when it comes to deciding where to go, or at least what the AI thinks, right? So they're confused. What do you do when it comes to that situation? And one of the ways to do that is to make the player guide the AI, and if the player guides the AI into an exposed position, then so be it, kind of thing. The other way is for you to have cues to the player to say something like, hey, get out of there, you're in an exposed position, come over here with us, that kind of thing. And that may not be a bad idea either. So we haven't really talked about how to coordinated movement with AI, and that's kind of a little bit out of scope for what we're doing in this course. But I wanted to mention it only because it is definitely a consideration when you're making a larger game. All right, so the last thing I want to talk about is what we're doing in Lab 8. And I'm keeping it very vague here because Alex and I are going to be adding in more actions for your assignment 4. Really what we're trying to do is help you as much as possible with Lab 8. And it's a small little lab. It should be worth, again, only 4% of your final grade. But remember that we're taking the best, I think it's 12 out of 14 lab marks. And that's even in combination. So even the one that's worth 3, as an example, that 12% or whatever, we're taking the best 12 combined lab marks and giving you the best mark we can. So this is an example of another one where you can use, even if your Lab 7 didn't go so well, but the other labs went really, really well, then at least you can take the best grouping of marks and you'll get those marks compared to some of the, if we were going to take all the marks or take into account every single mark. Okay, that's how it's going to work. Any questions around this before we kind of end for the day? So Lab 8, again, I said build more actions. You're going to see more details when we kind of build the lab for you coming up. But more or less what we said in our schedule, and if I go up to the schedule, is the things that we want to target are things like close combat attack. What does that look like? What does the range combat attack look like? The actual action itself for doing that, right? We've built so far things like, kind of the actions themselves and the conditions. We built conditions and actions, and the conditions basically are triggered. They can trigger basically if you're far away or close enough or whatever it's going to be. But there actually isn't any effect from those things at all. So I think for this lab, we're going to build an action so that the enemy can fire at the player or the target. That's the idea behind it. Okay, so that's what's coming up. Any questions before we go for the day? If there are none, reminders, things that we have to remember. Again, Lab 8, so the thing that's going to be hosted on Thursday, it's going to only be due this Saturday. That's different than what it was before. Normally we give you your labs and they're due Sunday. This time, no, because your assignment 4 is due Sunday. We don't want these two things to clash where you have two things due at the same time. So Saturday is your Lab 8. Sunday is your assignment 4. Okay. On that, again, please don't forget to start assignment 5 at this point. You can start doing that because you should already start being able to put together slides. Get those slides started to go so you have a base, share on Google Drive or whatever you're going to do, however you guys work together. Get the thing going so at least you have a base, and so it's not so last minute. Like you don't want to wait till Wednesday to get your slides ready. Start giving, scaffold out some slides, some stubs or whatever where you're going to add some detail in there. Make the headers, kind of all the headings for all the slides that I've asked you to put together, and then fill in the details when you have screenshots and those kind of things. And you should include screenshots, guys, and stuff from your assignment 4 in the slides to demonstrate. Remember, you want to make the presentation as interesting as possible for us as evaluators, but also fun for you guys as presenters. Okay? Any questions at all before we go for the day? Okay, guys, thank you so much. I'll see you guys all on Thursday. If you have a question, I'll stick around. If you have something you also want to ask, I'll stick around after. I'll stop recording now and take questions directly. Thank you. Any guys, anyone here have any questions?